Good morning, class. Welcome back to geometry. It's a rainy Monday morning. We're going to look at lessons 69 and 70 this morning. 69 first, of course. That is page 457. Lesson 69 is an easy lesson. It'll be a short lesson, thankfully. Talking about properties of trapezoids and kites. First things first, what is a trapezoid? It's a four-sided shape. Tell you that. It has four sides. And what else about a trapezoid? Hopefully you would understand that it is not a parallelogram. This is a parallelogram, four-sided shape, with two pairs of parallel sides. A trapezoid is a four-sided shape, but it is not a parallelogram. The way we often draw it is like this. One pair of parallel sides. So not a parallelogram, only one pair of parallel sides. This side is parallel to this side. This side is not parallel to this side. Obviously you can see that by looking at the drawing, but you could draw it otherwise, and if I say it's a trapezoid, you know it's one side is parallel to the other. Now, I'm stepping back and looking at this drawing, and it looks terrible, so I'm going to modify it a little bit to try to match slightly better. This is parallel to this. A couple terms we need to know. The bases of a trapezoid. A trapezoid has two bases. It's not just the bottom, although this is a base. This is also a base. If we label them A, B, C, and D, we could say that line DC is a base. We could also say that line AB is a base. So all trapezoids have two bases, bottom and top. It's not necessarily the bottom and top. You could turn your trapezoid like this if you wanted, and in that case this is the bottom and this is the top. But the bases are the one of the parallel sides. So this is a base and this is a base. Doesn't matter which way you turn it. Bases of a trapezoid, one of the parallel sides. Base angles, you could think of base angles as being in pairs. So angle D and C are a pair of base angles. Also A and B are a pair of base angles, and in that sense you could say that all the angles in a trapezoid are base angles. But think of them in terms of pairs. D and C are base angles, and A and B are base angles as well. And then the legs of the triangle, the legs of a trapezoid are the non-parallel sides. So this is a leg and this is a leg. Just terminology to orient ourselves to trapezoids. Now, thinking about, there's a bottom page 457, thinking about the mid-segment of a trapezoid, just like the mid-segment of a triangle, if you remember, back a few lessons ago, we draw a triangle, and we find the midpoint of this side and the midpoint of this side. And remember, the definition of a midpoint is a point that divides a side into congruent parts. So this is congruent to this, and this is congruent to this. That's how you could notate that this is the mid-segment. This is the middle of this side. So a mid-segment is a line then connecting the midpoints. This is a mid-segment of this triangle. Well, you can take the same thing for a trapezoid and find the middle of this leg. In the middle of this leg, draw a line, and that is the mid-segment of the trapezoid. Just as in a triangle, the mid-segment is parallel and all that, the same characteristics apply. So the mid-segment of a trapezoid is parallel to both bases, and it has a length that is half of the sum of these two sides. So if this is a mid-segment, then this is also parallel to both of these, and it is half the distance. So if this were 5 and this were 10, this would be, hopefully you say 7.5, 7.5. 5 plus 10 is 15, divided by 2 is 7.5. The mid-segment of a trapezoid is the average of the bases, is another way you could think of that. That is the trapezoid mid-segment theorem on the bottom page 457. And turn the page, you can see how that would apply, the problems that would come from that. All right, the middle of the page is a special kind of a trapezoid. Let's erase all this. Special kind of a trapezoid is one that, if I can draw it, again, parallel and parallel. An isosceles trapezoid is a trapezoid with congruent legs. Like isosceles triangles, isosceles trapezoids have congruent base angles. What they're saying is this is congruent to this. Now, the only way that these two can be congruent is, the only option we have is for this angle to be congruent to this angle. If we were to lengthen this one at all, that means they're not parallel anymore. No, I take that back. If we were to lengthen this, the only option we would have, find my eraser, the only option we would have is to make the angle greater. So this would be one way to lengthen this side. So it's kind of curved, but this side is obviously longer than this side, and obviously this angle is not the same as this. It's still a trapezoid, but it is not an isosceles trapezoid. An isosceles trapezoid is just like an isosceles triangle, where this side is congruent to this side. An isosceles trapezoid, this side is congruent to this side, or leg, as we call them, which makes these angles congruent. It also makes these angles congruent. The only other way you could draw this shape, if you had, if you want to keep these the same, is you would turn this one out here, and so if this is 7, and I give you a 7-inch stick, and I say put it in here, you could put it like this. You could also put it this way. However, if you put it this way, it would turn it into a parallelogram. As long as these stay parallel, and you try to put this 7-inch stick in here. So the only way that it can be an isosceles trapezoid is that these angles will become congruent. So base angles of an isosceles triangle are congruent. This angle is congruent to this one. This angle is congruent to this one. And one more property about an isosceles trapezoid is that the diagonals of an isosceles trapezoid are congruent. So remember, I've been harping about these rectangles that I make at the shop, and I'm trying to make a frame, and it's crooked, but I weld it together, tack it together, and then I measure. I measure across here and I measure across here, and if one is longer than the other, then I adjust it, and that makes everything 90 degrees and square with each other. Well, let's just say that I cut these pieces and I have a 10-inch and a 10-inch, and that's what I was aiming for. I have a 12-inch, and then I was aiming for a 12-inch on this one, but I actually cut it at 11 and a half, 11.5. I still tack it together, tack everything together, weld the corners, just tacked, and I measure it. I can still make these diagonals congruent to each other, and it will sort of be squarish. These won't be 90 degree, but they'll be congruent to each other. It's still kind of set in there just like this. This is extreme or exaggerated, but it will still be set in there where this diagonal is congruent to this diagonal. So properties of an isosceles trapezoid, it has congruent diagonals. This is congruent to this one. You just have one there. It's hard to notate that. But diagonals of an isosceles triangle are congruent. Of an isosceles trapezoid are congruent. All right, enough about isosceles trapezoids and trapezoids in general. We're going to turn to kites for one more property. If we draw a kite, remember the definition of a kite is a four-sided shape and two pairs of congruent sides. We draw it sideways like this. So this is congruent to this, and this is congruent to this. That's a kite, and it looks like a kite just on its side. If you draw diagonals of a kite, diagonal here, the diagonals of a kite always are perpendicular. And you would expect that if you look at a kite, the picture of a kite, if you ever made a kite, and you get the cross pieces in here, you make them a 90-degree corner, you put your tail on it, and there's your kite. And your string you attach here and here, and there you have it. The diagonals of a kite are always perpendicular. Excuse me. And I think that's it. I'm going to give you the homework for lesson 69, and then we will move on to lesson 70. All right, for homework for lesson 69 is as follows. Lesson 69 homework is 1, 7, 8, 14, 16, 19, 25, 26, and 28. Not 8, but 2, 8. All right, I'll say it again. 1, 7, 8, 14, 16, 19, 25, 26, 28. I think you can read that even with that glare.